Come here, come here. I want to show you something before the others come. Let me show you a little trick that we can do. If we take this screw away, we can get a twist bit which is just bigger than the head of the screw, but also matches up with a dowel size. And what we can do is can drill into this hole here and just make it bigger. Not all the way through, just about halfway, just to make it bigger for the screw head to fit into. And that will change the hole so it looks like this. Let's have a look. So if we put the screw back into place, you can see that we can lower it down now a little bit further like so. And if I get a short piece of dowel, remember that round stuff, then I can just put some glue in the hole and then shove the dowel into the hole like that and totally cover the screw head up. And we call this hole a counter bore. A counter bore. And it's a nice little trick to hide the head of the screw and make it look like a dowel joint. You don't know what a dowel joint is? Come on, let's do that next. Okay, let's get two pieces of wood up on the screen and let's have a look at a dowel joint. Now, the reason I'd choose a dowel joint over a screw joint is that it looks a lot better. But the reason I would choose a screw joint over a dowel joint is that a screw joint doesn't need glue, so it could be used straight away, no glue needed. Where a dowel joint you need to glue, and therefore you're going to have to wait for the glue to set. But it's only a small wait. So the first job is to drill a hole all the way through your piece of wood, again using a twist bit. Then we can take the top piece and line it up there with the bottom piece just to make life easier. Then again with a twist bit, I'll be able to drill through the hole into the lower piece, going as deep as I need to, creating a hole like this. So, good question. What drill size should we use? Well, that will depend on whether we're going to use plain dowel or the serrated dowel. As a general rule, you could just drill the same size. So, for example, if you've got diameter 6mm dowel that you're using, then use an M6 drill, a metric 6 size drill. However, with the plain dowel, I'd go 0.5 millimeter bigger or 1 millimeter bigger, just to give it room for the glue to really soak into the side of the dowel. Remember, the serrated dowel has got these grooves in it, and that allows the glue to sit in there, so you can have the same size of hole. Now, before I glue this up, can I just show you something else as well, which is of great interest? I'm going to drill a hole in the bottom of the bottom piece here. I'm going to do it a little bit deeper as well. And then I'm going to get this marking tool, which is called a dowel center. Can you see that it's got a very sharp point here in the middle? And the idea is that I put it into the hole like this. And I get my top piece of wood here and I put it down like this, line it up and then press it into place like that. And then that's going to leave a little mark on the underside of that top piece of wood. And then using that mark, I can get my twist bit into it and I can drill a hole. But this time, I'm not going to break through the surface. I'm going to stop so you can't see the hole. Now, let's take that dowel center out of the way. Then I'm going to add some PVA glue, remember, on here, this surface, and in the hole as well for the dowel. So use PVA wood glue for that. Taking the serrated dowel, I can now place that into the hole and let all the glue go up the grooves. And then I can take the plain dowel and position that in the hole as well with all that glue. Lovely. And then I'd place some glue on this dowel here and the serrated dowel here, before finally placing all of this piece here in place like so. And let's just bring that dowel into position so that you can see it, and then I would clamp up. Let's really clarify what's happened here then. I'm going to bring on this 2D view. And you can see here that the dowel is flush with the surface, goes all the way through the top piece, and we call this a through joint, okay, because it's gone through that top layer and you'll be able to see it. Where the serrated dowel one, we've placed in a hole which doesn't break through, so we call this a stopped joint, and you won't be able to see anything here. Here it will just be the wood itself. And this gives you a good idea that, you know, a lot of joints that we do can be either through joints or stop joints. Right, I've got two more butt joints to show you. Let's just get it a little space here. So one of the issues that we have with a butt joint is the amount of end grain that we see on the side. Now with hardwoods that's not a problem because you've got dense grain, but with softwoods they can be quite open grained and it doesn't look so good. So, you know, we want to try and reduce this end grain that we see in some cases. And we can do this by cutting a step out of the piece of wood so it looks like this. And we can do that with a tenon saw. So let's just write that in tenon saw, 10 on, just one N in the middle, tenon saw. And in doing so, we've now created a lap joint. And because we're using it in the corner, we then can call it a corner lap joint. I'm going to spread some PVA glue over this surface. Now don't forget we can use more glue now on this other surface here because we've now increased the surface area. It could go all the way down there as well, which is another advantage of this butt joint. Taking this top piece now, we can slot it in there and clamp that up into position. And you could even pin this with a couple of nails to hold it in place. And this final joint for today is going to get rid of all the end grain. So this is called a mitre joint, and it's probably the most sophisticated butt joint for me anyway. So if you ever see the word mitre in design and technology, then it will mean 45 degrees. So if I cut this piece of wood at 45 and I cut this one at 45 degrees, then when I glue them together, I get back my 90-degree angle. Now I can place some glue here on the mitre and on the other side too if I want. And then I can bring the mitres together and just glue them up there to get the 90 degrees. Now I've made that quite sound quite easy, but one of your first problems will be to get the 45-degree angle cut. So you could use something like this called a mitre box, which you can put your tenon saw into to get the 45 degrees, or you can use the more fancy mitre saw, which will get you that angle, and then you can just sand it up a little bit with a belt sander to get it perfect. And then the other issue is when you clamp your work, the mitre joints, they tend to slide up and down each other like this. So this is something that you've got to prepare all 4 mitre joints ready to glue up at once. And then the easiest way to set them all together is with these web cramps, which I'll just write that in there. These are cramps. And because they've got this webbing which goes all the way around the product like this and holds those 4 corners in, then we call it a web or a strap cramp. So let's just make that clear. Web cramps and a mitre saw. Great. And let's put a reminder here that a mitre joint is at 45 degrees. See that word mitre, 45. Now I have also seen that some people refer to a dowel joint and a mitre joint as under the classification of a frame joint, and that these 3 guys over here are all carcass joints. But the butt joint is quite versatile, and I would say that it could fit for either of these cases. And if you want to see some real frame joints, then come and join me for video 3 on wood joints.